Lesson 9. It's the 19th of the 11th. Are you ready to rock? If so, here we go. Okay, we are subtracting fractions with different denominators today. What am I looking for? Well, ladies and gents, it's up to you to choose the best strategy. And to be fair, I know which one I prefer, but hey, you've got freedom of choice. First thing then, okay, strategy number 1, subtracting and then subtracting the fractions by kind of doing an exchange of fractions. So more of that in a bit. And the second WILF or strategy that we're interested in today is converting to improper fractions and then back to mixed numbers with the final answer. And between you and me, that's my strategy. Anyway, vocabulary, thank you. Mixed number fraction, convert improper fractions, LCM and LCD. And I guess exchange should be there as well. Okay, are you ready to rock? Let's go for some discover. Here we've got some information given. Right now we've got Isla and Max. We've got a recipe book open with various fractions of amounts. 3 1/3 cups of cherries, 2/3 cups of sugar, 1 1/2 tablespoons of corn flour, 3 1/2 tablespoons of milk, and 1 sheet of pastry to make a delicious cherry pie. It looks like Max has got a bowl of cherries, and it looks like there's 1 1/2 cups of cherries in that bowl. Okay, Isla is obviously talking to Max, who's replying. I wonder what they're saying. Let's reveal. I wonder how many more cups of cherries I need, says Max. I need to find 3 1/3 subtract 1 1/2. Okay. And then Max goes on to say, but in doing that, I can't find 3 1/3 subtract 1 1/2 because 1/3 is less than 1/2. And then Isla's saying, well, do the subtraction if you change both the numbers to improper fractions. So basically, Max needs to subtract 1 1/2 from 3 1/3. Let's have a look at the information. All right. I wonder how many more cherries are needed to find 3 1/3 subtract 1 1/2. And I can't find that because 1/3 is less than 1/2. So the problem is asking, is Max correct? Can you subtract 1 1/2 from 3 1/3? Because 1/2 is more than 1/3. Or in Max's words, 1/3 is less than 1/2. Let's find out. All right, is Max correct? He says you can't subtract 1/3, okay, because it's less than 1/2. Well, this is strategy number 1, and we are introduced to this strategy with this piece of advice. I needed to find 3 1/3 subtract 1 1/2, and to do that I rewrote 3 1/3, the larger of the fractions, as 2 4/3 to make the fraction part bigger than 1/2. So then you can subtract it. So what the lady is saying, 3 1/3 is equivalent to 2 4/3. So let's see what that looks like and how that helps us to subtract. Here we go. All right, 3 1/3 as 2 4/3. Here's our original fraction, 3 wholes and 1/3 of a whole, 3 1/3. And if we represent it on our bar diagram, we can see we have got 1 whole, 2 wholes, 3 wholes, and there's our third. We're good with that. 1 whole, 2 whole, 3. So there's our 3, our integer, and there is our third, our fraction of a whole, 1 out of a possible 3. Yeah, I like that. Okay, so what she's saying is that is equivalent to 2 4/3, 2 whole integers, and then 4 out of 3. So that means that's an improper fraction. What does that look like? 2 4/3. Here we go. So we've got the same bar diagram, exactly the same size. This time we've got the sections split into 1, 2 wholes, and then 1, 2, 3. So that whole number is split into 3. So therefore each section must be 1/3, and there's our third. Okay, let's see what that looks like. 1 whole, 2 wholes, and then we've got 1, 2, 3, 4. So that is 2 4/3. And you can see that they are exactly the same equal value. So 3 1/3 is the same as 2 4/3. So I kind of exchanged one whole here for 1, 2, 3/3, and then put it with the third to give us 4/3. Oh, okay, I can see that. So that now changes our calculation, which was initially 3 1/2 subtract 1 1/2, okay, to this. Instead of 3 1/2, 2 4/3, and we are going to take away 1 1/2. And that now is slightly easier with. Next step, subtract the whole numbers. So we've got 2 subtract 1 gives us 1 whole. All right, don't forget that. We need to pick that up at the end for the final answer. Now we're dealing with the parts, and we've got the equivalent to 3 1/3, 2 4/3. So we've got to sort the 4/3 and subtract a half from it. So 4/3 subtract our half. But of course, we got a problem, and the problem is the denominators are not the same. So we need to find a common denominator. So it looks like our lowest common multiple of 3 and 2 is 6. So we're dealing in sixths. I need to convert 4/3 and a half into sixths. Okay, let's do it. So 4/3 turns into 8/6, because 3 times 2 is 6, the denominator, and what you do to the bottom, you do to the top. 4 times 2 is 8. Don't need to explain that because that's the previous few lessons. If you want to find out more, you can message me. So how about a half? Shout it out. What would a half be in terms of sixths? I hope you said 3/6. Absolutely. Now we're in a position where we can subtract the numerators because the denominators are the same, they're the equal value. Here we go. So that now leaves us with 5/6. Now, we're not ready to quite finish our calculating because we need to put together our final answer, which, of course, don't forget the 1 we've got from subtracting the whole and the 5/6. So our final answer now. Max is not correct, as he can subtract those two amounts, but he has to convert 3 2/3 to 2 4/3. So in that case, how many more cherries does he need? He needs 1 5/6 more cups of cherries to be able to make that delicious pie. Now, that strategy number 1, using an exchange of whole and turning them into their fraction equivalents, is tricky to get your head around. So if you're not too confident on that right now, how about a second strategy? This time we're going to look at Isla's method. Remember, she says you can do the same subtraction if you change both numbers to improper fractions. Okay, so what's the question saying? It says, show how Isla's method will give you the answer to 3 1/3 subtract 1 1/2. So remember, we don't need to do any exchanging now. So we're just going to take those whole numbers and fractions for what they are. Change both numbers to improper fractions. All right, here we go. So 3 1/3. This is what it looks like here. We've got 1, 2, 3 whole and a third. So turned into in its equivalent as an improper fraction, we have 1, 2, 3, 4, 5. 10. So you've got sections of a third because there are 1, 2, 3 and a third. So in terms of an improper fraction, let's count. How many thirds will that be? 1, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3. So as an improper fraction, 3 1/3 is equivalent to equal value to 10/3. Yeah, I get that. So what about the other fraction, 1 1/2? Here we go. All right, let's represent 1 1/2 on our diagram. See if I can read that. So, okay, we've got one whole section there in blue, and we've got half of a whole section. So that must be representing the 1, and this part must be representing the half. But as an improper fraction, it looks like there are 1, 2, 3 of these halves. Let's check. Half, yep, that's a half, making a whole, and that's another half. So we have got 1, 2, 3 halves. So 1 1/2 is equivalent of equal value to 3 halves. Right, so what next? We need to find the total. 3 1/3 subtract 1 1/2. Well, first thing, okay, 3 1/3 subtract 1 1/2 can be written as 10/3 take away 3 halves. Yeah, we've calculated that from the diagrams in this bit at the beginning. So what next? Well, you know what. So now we've got 10/3 and we're going to subtract 3 halves. But we need to find a denominator, a common denominator, and our lowest common multiple for 3 and 2 will be 6. So we need to convert both of these fractions into 6. Okay, so to get to 6 from 3, we multiply by 2. To get to 10, we need to multiply by 2. So our equivalent is 26. And the same, here we go, for 3 halves. To get to 6, we need to multiply by 3. So 2 3s are 6. And to get from our numerator to our new numerator, we need to multiply by 3 as well, giving us 9/6. So we've got a totally different calculation now, but the denominators are the same. So we can simply subtract the numerators, giving us 11/6. All right, I like that. But 11/6 is an improper fraction, so you'll need to convert back. And we'll need to change it to a mixed number. And 11/6 converts to 1 5/6. Because how many 6s are there in 11? Well, there's not enough 2 lots of 6 because that's 12. So there's 1 lot of 6. There's the whole. And there's possibly 5 out of a possible 6 left, giving us an answer of 1 5/6. And that's the number of cherries, cups of cherries that Max needs to complete his recipe. So, okay, 2 methods, the exchange method and then the improper fraction method. How about you have a go? Let's have a look. Let's think together. Now, this looks rather complicated, I do agree. But I'm just going to read it out to you, then I'm going to give you a moment when I press pause to have a go at populating the missing parts. So 1A, think together, says work out 4 1/3 subtract 2 3/4. And we've got ourselves some diagrams here. Okay, so it might be worth just considering what do the blue bits on the diagram represent. And here we have another diagram representing an exchange. So this is talking about strategy 1, where you're taking one of the whole and you are converting it into its fraction parts. Okay, then we've got a calculation to complete. It says 4 1/3 is the same as 3 plus 1 1/3, which is the same as 3. And that looks to me, because it's an improper fraction, that numerator needs to be bigger than the denominator. Okay, then it's asking to subtract the wholes, then finding the lowest common multiple of 3 and 4, and then you've got the parts to complete. Here's a diagram that might help you to populate these parts to therefore give your final answer. Anyway, have a go. Pause. All right, ladies and gents, so before the pause, I asked you to work out, using strategy number 1, that exchanging wholes for parts. All right, work out 4 1/3 subtract 2 3/4. Let's have a look and see what on earth all of this means. Yeah, it's complicated. Here we go. Okay, let's have a look at diagram 1. We've got here 4 1/3. We're going to focus on that. The first diagram looks at splitting the wholes into 1 whole, 2 whole, 3 whole, 4 whole. So there's the 4, okay? Now a whole represents 3/3 because this is dealing in thirds, this particular diagram. All right, so we've got 1, 2, 3, 4. Yeah, we're good with that. Leaving, you've guessed it, a third. I like it. So we're cool with that. But We're talking about strategy 1 and exchanging. So how about 2 3/4? Well, we're not on that bit yet because we need to now think about converting our 4 1/3 here into something more manageable so we can subtract 2 3/4 because 1/3 is less than 3/4 and that's quite tricky to deal with. All right, so where do we get to? Second diagram showing the exchange, and it's something about this bit here. What have we got to find the equivalent to 4 1/3? Well, we've got 1 whole, 2 whole, 3 wholes. Good. And this next whole has been split into an improper fraction because there's 1, 2, 3, 4 thirds. So we've got 1, 2, 3 wholes and 4 thirds, which leads us to our first populated answer. Here, 4 1/3 is the equivalent to 3, okay, and 4 thirds. So as I've highlighted, we're interested in this diagram now, what that represents for the rest of the calculation. So I've crossed out 4 1/3 and I've crossed it out in the question, but we're still keeping an eye on what we're subtracting because we've converted 4 1/3 into 3 4 thirds. Right, remember that. So we are now going to subtract 3 4 thirds, subtract 2 3/4. Here we go. You know what to do about subtracting the wholes. So we've got 1, 2 taken away from 3 possible wholes, leaving us with 1. All right, remember that for later. You need that for the final answer. Now, because we are dealing in 3s as the denominator and 4s, we need to find the lowest common multiple of 3 and 4, and you've guessed it, of course, it's 12. So everything needs to be converted into 12ths. So let's deal with the fractions. So we've got 4 thirds, and we're going to subtract 3/4. All right, and here we need to convert into 12ths, which will give you 16 12ths. Take away 9ths. Can subtract the numerators, giving us 7 12ths. All right, 16 12ths, take away 9 12ths. And this diagram here, each section is split into 12ths. And the blue represents the 16 12ths, and the 9 is represented by the crossed out. So we are subtracting, leaving us with our 1, 2, 3, 4, 5, 6, 7 12ths of an answer here. Now we can start to put things together. So 4 1/3, subtract 2 3/4 will give us a whole 1 and 7 12ths. Put together 1 and 7 12ths. I don't know about you. I definitely need a cup of tea. Whew, brain power or what? Okay, how about the second method? So I'd like you to work out 3 1/5, subtract 1 1/2 by converting each of those mixed numbers to improper fractions. Pause the video, have a little go yourself, and then let's see how you got on, and I'll share the answers. I'll be back in a mo. Okay, so before I paused, I asked you to work out 3 1/5, subtract 1 1/2. This time by using that second strategy of converting your mixed numbers into improper fractions. Okay, here we go. Give yourself a tick if you manage to complete 3 1/5 converted into an improper fraction will be 16/5. 1 1/2 converted to an improper fraction gives me 3/2. So it's just saying now, how else can that be written? Well, it can be written as 16/5 subtract 3/2. But the problem is the denominator. So we need to find the lowest common multiple of both 5 and 2, and you've guessed it, of course, it's 10. So now we need to find the common denominator. We've got 5 and 2 as denominators, so we need to convert 16/5 subtract 3/2 into tenths. And of course, we will have 5 multiplied by 2 gives us the 10th. 16 you multiply by 2 gives us 32. So 16/5 is equivalent to 32 tenths. What about 3/2? Well, okay, we need to Multiply the 2 by 5 to give us 10, the denominator, and what you do to the bottom, you do to the top. So 3 times 5 is 15. And now we're left with two fractions that we can subtract. The denominators are the same, tick, and we've got a larger and a lesser. So 32 subtract 15 gives us 17/10. All right, now we need to do the changing back to a mixed number. So we've got our 17/10, and don't forget 1 and 7/10 gives us our final answer, because 10 divides into 17 once, and there are 7 out of a possible 10 left over. How do you feel about that? Wow. Okay. It's your turn. And if there's anything you're not sure about, as I whizzed through the 2 different strategies for subtracting, you know where you can find me or Mr. Horn. Here's your chance to show, and lots of space to calculate, to work out. Yeah, I'll leave it to you to choose which strategy is best for you. And the little cat here, use whichever method you feel happy with. Just go with what feels right. And for me, if I were doing this, I'd convert to improper fractions. So here are 2 out of the 3 pages. Here's the final page with the reflect. Again, it says about reflecting, doing some work with a partner. Ignore that. What you can do is explain your reasoning to me using the vocabulary from the start and through the tutorial. If you fancy a little bit more of a challenge, we got a tricky one here using a number line. So that takes fractions to a different level. All right. And then that is today's lesson, over and out. Really well done, people. Can't wait to take your work in. So crack on. Any problems, you know where I am. Contact me on Dojo. In the meantime, take care. Bye for now.